Hi everyone, in this video I'll be demonstrating how to solve question number 2 from assignment 7, which is yield Smokehouse. So the first thing I'm going to start by doing is adding my algebraic equations. So in this case we have 3 variables, and they're named this time instead of just being A, B, C, and D. So I'll start by identifying each one. So x1 is the taster's delight. X2 is the succulent delight. And X3 will be the gourmet delight. And then the next part is I'll be identifying the maximum profit equation. So I'll add that this is a max problem. So to do that, we're maximizing our profit. So we'll look at our profit per gift for each of the variables. So in this case, x1 is $2.50. x2 is $3.50. And x3 is $4. I'll label that profit per gift. And then I'll add in the constraints because there are some limits. So there's going to be 3 constraints that we'll have to put in. The first will be for the number of sausage that can be used. And you can see in the problem that it tells us that there's a maximum of 2,500 sausages that can be used. As you can see in the table, it tells us the number of sausages for each of the variables. So for x1 has a limit of 3, or it uses 3. x2 is 5. And x3 is 6. And we'll have to stay under that 2,500 limit, so we'll do less than or equal to. Next we'll move on to the cheese constraint. So for x1 it will be 6, x2 is 4, and x3 will be 5. Again, it will have to be less than or equal to. In this case, there are 3,000 cheeses available. And then the last step is we always have to identify that our variables cannot be less than 0. So x1, x2, and x3 must be greater than or equal to 0. I'll label these. So now I'll start setting up some of the formulas here. So, and for these types of problems, for the linear programming problems, the setup and organization is very important, especially as the problems start to get more complex. So make sure you take your time and are careful when you're setting up the problems. So I'll start by labeling the columns for each one of our variables. And then in this case, we're looking at the numbers to make in order to maximize the profit. So since the numbers to make is going to be the fields that we're changing the values to, I'm just going to add some color coding to help keep that clear. And I'm also going to add the profit per gift that's given to us in the problem. And because these are monetary values, I'll just change the cell formatting. And then we'll also be what we'll be calculating is the maximum profit. So I'll add another color code so we can keep that identified. So I'll make that green. And the next thing we're going to do is we're going to start by adding in our constraints, which is the number of sausage and the number of cheese. And we can look at either our algebraic formulas to figure out the different amounts used for each gift package and also the limit, or we can look at the table in the question. So I'll start by adding each amount used for each variable. And I'll label this column used. So this will be a field that's calculated. It'll tell us how much of each constraint was used. I'll make that yellow. And then I'll also put in the total amount that we have available, which is 2,500 and 3,000. From here I'm going to start putting in our formulas. So to calculate the max profit, it will be the numbers made for X1 times the profit per gift. And we'll do that for each one of our variables here. And it's a good idea to double check your formula here, because this is going to be one of the final answer that we're looking for to make sure that it's correct. And everything looks good, so we'll move on to putting in the formula for our constraints. So this one will be the number used times the amount of gift packages made. I'm going to lock that in. I'll continue that for the rest of the variables. Again, it's a good idea to just double check, make sure everything's the way you meant it to be. Well, I can hit enter there, and we can drag it down. And that's why I locked in the variables for the numbers to make, so I could just drag it down and won't have to retype in the formula. So from here we can move on to using Solver to figure out our answers. So the first thing is setting our objective cell, which in this case is going to be the maximum profit cell. We're going to make sure that it's set to max because we're trying to maximize that value. And then we're going to set the cells that we're going to be changing the variables, which is going to be our numbers made for each item. And now we can start by adding our constraints. The first thing I'm going to do is I'm going to set x1, 2, and 3 that they must be greater than 0. Select add. And then in this case, we can add our constraints for the sausage and cheese used. And it must be less than or equal to the constraint cells that we've already added. Now from here, make sure that simplex LP is selected, and you can select solve. Hit OK to lock in the values. And we can just double check our numbers here. So x1 should be 278, which this is just a rounding thing, so it's okay if it's a little bit off. If we reduced how many decimals it showed, it would round up to 278. Our succulent delight is 333, and then our maximum profit is $1,861.11, which matches up with the answers provided. So that is how to solve question number 2 in assignment 7.